saw an email for rats is that you have to pay another time to actually walk, right?
If you pay the graduation fee, that should be it, unless you're talking about rentals for.
So the 115 and that's it.
It should be just be the 115. Yeah,
Okay.
you shouldn't pay that again. Yeah,
Okay,
don't pay that more than once.
It's like because I saw the email say, yeah, it's two separate fees.
Oh, I'm not sure about that. If you want, you can send me the email so I can take a look. So yeah.
I think I have one more. Maybe you have times. I'm gonna email it to you if you don't mind.
Okay, yeah, no problem.
All right, thanks.
Yep.
For this one, if I consider like this a positive axis. For the element, it will be like positive.
Yep.
This is my variable minus 400.
Maybe 135.
Yeah.
Yeah, because you started at the like number you go with that.
For this, it should be like that.
Yes.
Right, so using that value, like 45.
Yeah.
135 and 0. Actually, I kind of worked this out. So like sign and everything is correct, but my answer is not.
Okay. Send an email because I need to cross-reference it with the solution. So yeah, you just send me what you have.
But it kind of messy.
I know. That's the
This might there might be an issue with the values.
probably most likely. Yeah, either with the values or maybe how they're assembled. So yeah, I'd have to kind of process the solution. Yeah, just scan it and just send. I know it's a lot.
Understand if you can understand.
By second?
I just scan and.
Oh, yeah. No problem. Yeah, no problem. Yep. What's up?
Have you played Helldivers yet?
I haven't. I've watched my friend play it.
Great.
Or it's more like I've watched my friend sit in queue trying to get on the server for like 3 hours.
They upped the server cap.
Oh, really?
You can get it now no matter.
Oh, okay, all right.
What. It's weird.
Nice.
Try it out. Oh. No, in the fucking games, I mean. What do you mean?
All right, it's 5:30. Let's go and get started. All right, good evening, everyone. How's everyone doing today? Doing good, doing good. All right, so the plan for today, we're just gonna keep just chugging right along. So we're continuing on with our MATLAB review or MATLAB tutorial, however you want to call it. So on Tuesday, what we did is we covered the basics of MATLAB. So we talked about defining variables, how to manipulate variables, just kind of general structure of the MATLAB interface, the toolbox, the workspace, the scripts. So today we're going to get into a little bit more advanced stuff. So we're going to get into control statements, if statements, else statements, and for loops, and how to plot stuff in MATLAB. So these are all skills that we're going to be using very soon. And so definitely would be good to get used to them now. Okay. All right. So announcements, remember activity one, answer activity one together with all the extra problems at the end. That is due end of this week. We are gonna have a midterm soon, so not next week, but we're planning for the week after that. So I think what I'll do next week, early next week, is we'll talk about the midterm a bit more. We'll talk about kind of what's going to be on the midterm, what's going to be expected, the format for the midterm, and everything you need to know for that. So again, midterm's not next week, but we're planning for the week after that. Okay. All right. I think that's all my announcements. Are there any questions I can answer before we get started for today? Okay. All right, so let's go ahead and get back to it. And so I already have MATLAB open. I was actually using it for my previous class. So here is the script that we had. Okay. And just to kind of remind you, we're for today we're working basically completely in the script mode, and so we're not going to be using the command window at all here. So we're just going to be using the script. And so just a reminder that MATLAB will execute your script from top to bottom, right? And so when you're writing a script, when you're writing a code in MATLAB, if you read it kind of from top to bottom, where each line is an individual instruction for the code. That kind of baseline, that kind of understanding will help you out a lot today. Okay. So let's get to it. Okay, so we left off right here for if statements. Okay. All right. So again, on Tuesday, we covered kind of the basics of MATLAB. So kind of how to get started, how to write lines of code, and what each line does, right? As you start to write kind of more and more complicated programs and more complicated scripts, right? There will be parts in the code where you want the code to do something different. Either execute a different line of code or assign a variable differently or compute something differently, depending on certain situations, right? And a lot of times, you don't know what those situations are going to be like before you start the code, right? And so to kind of account for this, to kind of make sure that the code can do different things depending on the situation, we can write if statements, right? Excuse me. So if statements, if statements are really nice because they read almost very much like in plain language. And so the reason we call it an if statement is that we read it just like if something were to occur, and if something does occur, if that condition is true, then we do what's inside the if statement. Okay. And so the anatomy of an if statement looks just like this, right? in essence. Right? So you can see the first part is we started with the keyword if, and what you'll notice is that when you type the word if in a MATLAB program, it'll highlight in blue. And so what that tells you is that word there has some kind of special purpose in the programming, right? So when things highlight in blue or highlight in another color, it's going to be something different than normal code. Okay. The next part of the if statement is what's called the check condition. And so the check condition is a statement. We'll go over in a second. It's called a Boolean statement. So it's a statement that can either be true or false. Okay. And so the program is going to check to see if that check condition is true. If it is true, then the code moves on to the body of the if statement. Okay. And then it executes whatever is in the body of the if statement. If it's false, then what it does is that it skipped over the body and just moves on to wherever it sees the end. Okay. And so an if statement, you can kind of think of it as kind of like a forking path. And so whenever you have an if statement in your code, right? It can either do one or two things. And so if the condition in the if statement is true, what we're going to do from here is we're going to execute the body, whatever's inside the if statement. Right? Whereas if false, right? If an if statement is false, then we're just going to skip to the end. As I write this in serial killer font. Okay? And so that's whenever you see an if statement in a code, or whenever you need to write an if statement, that's kind of the flow chart that you should kind of make in your mind. Is that, you know, this is kind of when the code's going to branch off and do different things depending on what I tell it, depending on what that condition is. Okay. All right, and also note that, you know, even though just for the sake of space here, I only have one line of code inside the if statement. Just know that you can have as many lines of code as you want inside the if statement. Okay. Okay. So here are a couple of examples, right? And so on the one hand, we have an if statement here. So the Boolean condition here depends on the value of this variable right here called needs correction. Okay. And in fact, let me actually write out this. Let's do this example live. Okay. All right. So let me go ahead and delete this. This is from last time. We don't need this anymore. Okay. Let me leave this note here because that's important to remember. Okay. So let me define a new variable. So we'll define a new variable. We'll call it needs underscore correction, and we'll set it equal to 3. All right, so now I'm going to write an if statement. So I'm going to write if, and then the way to start an if statement is that it gives parentheses after that. Okay. I think the parentheses are technically optional. I think you can write an if statement without the parentheses, but you know, I was always taught to put parentheses there, and alt habits die hard, so I put that there. Okay. And so remember, inside the if statement, inside the parentheses that goes right next to the if, we need to put a check condition. So we need to enter a condition that's either going to be true or false. Okay. And so the easiest and the simplest thing that we can do, the simplest statement that we can make that to either result in true or false is an inequality statement, right? All right. And so the condition that we're going to check here is that if needs correction is less than 5, right? Then we're going to enter into this body, right? Right, and then if we need to correct this this variable here, and so if needs correction is less than 5, then we correct the value and we set its value equal to 5. Okay. Okay. So let me go ahead and do that. So actually, let me clear all. Okay. All right, so when we run this code right here, you know, we're first going to define a variable. So we're going to define the variable as 3. Okay. Then we're going to check. So we're going to check to see if needs correction is less than 5. And so in this case, at this point in the code, needs correction is less than 5. Okay. And then if that's true, then we're going to go into the body of the if statement. So the body of the if statement is right here. Okay. And we're going to overwrite the variable to be 5. Okay, and so for this code in particular, this is a case where the if statement is going to return true, and so we're going to enter here and correct the value. And so what you're going to see here is that after this code runs, this variable called needs correction is going to have a value of 5. Okay, all right. So let's go ahead and run it. Right, and so you can see here that we have one variable that was created, and it has a value of 5. Right, because that's how this if statement is defined here. Okay. But if we were to change this, variable, so let's say we change this variable to 8, okay? Right? So once again, we're going to run this code, and every time we run the code, it's going to read the code from top to bottom, okay? And so it's going to read the code from top to bottom, and so first thing this code's going to see is that we're going to define this variable as having the value of 8, okay? Next, it's going to check, and so if this variable is less than 5, in this case, this is false, right? Because needs correction is 8. 8 is greater than 5, so this statement here is going to be false. And so since this is false, we're going to skip to the end. We're not going to execute anything in the body, and then needs correction is going to maintain its value of 8. Okay. All right, so let me go ahead and run this code just so that you can see it, right? And so if everything works out correctly, this needs correction variable is going to equal to 8. All right, and so I've run the code, and you can see that this variable here needs correction does indeed have the value 8 because we did not go into the if statement. The if statement was, you know, not satisfied here. It was false. And so we skip everything in the middle here, and we just skip to the end. Okay. All right, so that's the basics of if statements. And so I know this is a very juvenile example here, and so this is not actually code that you would actually write, but it is good to kind of know just for kind of illustrative purposes, so you can kind of see in practice how an if statement is formed. Okay. Any questions on this example here? Okay. All right, so let's get back here. Okay. All right. Actually, let's work on this example a bit more. Okay. So we can chain if statements as well. So we can write another if statement here. Okay. Let's make another if statement on needs correction. So if needs correction is greater than 7, okay, and then what we're gonna do is we're gonna reset its value to 7. Okay, so what we have here is a series of if statements. We have two in a row. Okay. And so we can see right here that we have needs correction. So once again, every time you hit run, the code is going to run from the top bottom. So it's going to start from the top line and run downwards. Okay. Okay, so let's read this code from top to bottom. So we have needs corrections equals 8. First, we're going to check if that value is less than 5. It is not less than 5, and so we're going to skip this entire first if statement here. Okay. Next thing we're going to check here is that if needs correction is greater than 7. In that case, it's true, because we haven't changed the value of needs correction yet, so that's still value of 8. And so from here, the value of needs correction is going to be 7. Okay. All right, so let's run this code. And you can see here that after I ran the code, the value of needs correction has been set to 7 because of the second if statement. Okay. All right, I'm going to do just one more example here. So let's change this to 3, and let's see what happens. Okay. So if we change this value to 3 right here, let's again kind of read the code from top to bottom. So we set the value of this variable equal to 3. First thing we're going to check to see if needs correction is less than 5. It is less than 5, so 3 is less than 5, and so we set the value of needs correction equal to 5 here. Okay. Next thing we're going to check is see if the value of needs correction at this point in the code right here is greater than 7, right? And so at this point in the code right here that I'm kind of highlighting right here, at this point in the code, needs correction has a value of 5. Okay. And so since at this point in the code, the variable has a value of 5, it is not greater than 7. So the second if statement returns false. And so we skip the body of this if statement here. Okay. And so by running this code as it is, needs correction should have a value of 5 at the very end. Okay. And in fact, it does indeed happen. Right? So needs correction is equal to 5 in this point. Okay. Okay, so there's a lot of really interesting things you can do with if statements. You know, things definitely get tricky, I think, once you have a lot of if statements together. But again, you know, the thing with programming is that I think people get overwhelmed when they see a lot of lines of code. But, you know, if you just always remember that MATLAB codes are read from the top bottom, and you kind of take each code individually and kind of try to parse out kind of what's happening on each line of code, I think it becomes a little bit easier to follow. Okay. So let's expand on this. And so the if statement is not the only control statement that we have. And so the next one that we have is called an else if statement. Okay. All right. So an else if statement is kind of an addition. It's kind of an additional feature to an if, because sometimes you want to check more than one condition, right? And so if condition 1, if that one fails, right? So if condition 1 returns false, then we can check a second condition within the if statement as well. So we have if, else if. Okay. And then we're going to check if condition 2 is satisfied. Okay. And if condition 2 is satisfied, we're going to do everything in the body of the else if. If not, then we're just going to go to the end. Okay. All right. So this is where things get a little bit tricky, because, you know, we're checking multiple conditions here. But it's important to note that if you're doing multiple if statements or multiple if else if statements, only one of these can return true. And so as soon as one of these return true, then we kind of do what's in that body, and then we skip to the end. Okay. So for this example here, so let's say that condition 1 returned true. And so if condition 1 returned true, then we're going to do everything in this body here. So we're going to do this work. And then even if condition 2 were true, we're actually going to skip that because the first if statement satisfied this, and so that's what it returned true. Okay. So if both condition 1, condition 2 were true, we only do the first part here. Okay. If condition 1 were false, but condition 2 were true, then we skip the first part and we do the second part right here. Okay. If both condition 1 and condition 2 were false, then we kind of skip the whole thing and we just skip all the way to the end, right? And so there's a lot to check here. So there's a lot you kind of have to keep track of, and so make sure that you're kind of keeping track of everything here. Okay. All right, so let's do a live example. So let's go ahead and see what this looks like. Okay. All right, so actually I'm gonna keep this one here. But instead of having a second if statement, I'm going to embed it in here. Okay, so next thing I'm going to do is, so if, else if needs correction is less than 7, okay? We're going to set its value equal to 7, okay? Okay, so this is a good example here because we have a situation where, you know, we're writing or we're reading our code from top to bottom. Okay, so at the top of this code, we're defining a variable here needs correction is equal to 3. Okay, first thing we're going to check here is that if needs correction is less than 5, right? And so in this case, needs correction is less than 5, right? And so we're going to execute this and we're going to set needs correction equal to 5, right? And since we executed this part of the if statement here, we're going to skip everything else, right? And so even though at this line of the code needs correction is equal to 5, which is indeed less than 7, right? And so this second conditional will return true. The fact that we did this part right here and this part was true means that we're going to skip this part down here, okay? All right, so when I run this code, our one variable here needs correction should have a value of 5. Okay? And in fact, let me clear just so it's gone. Okay. All right, so when I run this code, you should see that this needs correction variable is going to equal to 5. Okay. And in fact, that is true. So even though the second condition right here is true, we don't actually execute. Okay. Now let's look at a situation where the first condition could be false, but the else if is going to be true. Okay. All right, so in this condition here, we have needs corrections equal to 6. And so since 6 is greater than 5, this first condition is going to be false. And so that's going to be, you know, we're going to skip this entire first section here. Okay. Then we're going to, since the first condition returned false, we're going to check this one here. Right. And so next thing we're going to check is that if this variable is less than 7, 6 is less than 7, so that's fine. And so we're going to return this right here. Right. And so we're going to set our value equal to 7. So after this code right here, our needs correction variable is going to equal to 7. Okay. All right, so let me go ahead and run the code. And in fact, we do see that. And so after we ran the code, we can see needs correction is set, its value is set to 7. Okay. All right, one last demonstration here. So let's now set a value for this where it's all going to be equal to, it's all going to be false. Okay. Okay, so if I set this variable equal to 14, now both of these conditionals here will be false. So 14 is not less than 5, so that's false. And 14 is not less than 7, so that's also going to be false right there as well. Okay. All right, and so if we run this code, we should see that the needs correction variable is not going to be set here. And so it should retain the same value that it started with this, which is 14. Okay. Right, and indeed that is the case. Okay. All right, so else if statements are really powerful. They're a really nice tool. Where again, you know, let's say that you want to control what your program does under certain conditions. Okay, the else if kind of gives you a nice kind of logical expression here to account for kind of multiple scenarios. Okay. All right. Any questions on the else if statement here? Okay. All right. So that's else if. The last kind of control statement that we'll add here is an else statement, okay? And so an else statement, you'll see that the else statement does not have a conditional to it, and so we don't have to add any kind of true or false statement, because an else statement is kind of like an all else, if all else fails kind of condition, okay? And so an else statement only executes if all the conditionals, all the previous conditions in the ifs and the else ifs, if they all fail or if they all return false. Okay. Because traditionally, for just an if statement or an if else if statement by itself, if everything fails, if everything returns false, then we just skip to the end, right? And so we don't execute anything. But sometimes you might have cases where, if the first two conditions fail or the first three conditions fail, we still want to do something, right? And so we still want to kind of execute a line of code or do something in the code or compute something because we're going to need it later, right? And so the else statement kind of gives you a chance to kind of, it's almost like a fail statement. So if everything fails in the if statement, then something is there to catch it. Okay. Okay. So let's again do a live example here. So let's come back to the code. Okay. All right. So I'm just going to add to this. And so notice how, the if, else if, and else, they all belong to the same block here. So they all have the same end statement here. Okay. Oops, let me erase that. Okay, so here is an illustration of how an else statement works. And so here we have just a simple if, else if, okay? And so if needs correction is less than 5, then we're going to execute this first line of code here. Then the else if, we're going to check if it's less than 7, okay? Then we're going to execute this line here. But if both of those conditions fail, then we can execute this line of code down here, okay? All right, so this is a case where both of those conditions are going to fail because we're starting with the value of 14 for needs correction, okay? First, we're going to check if needs correction is less than 5. It is not, it's false. And so we're going to skip this part. Next, we're going to check to see if needs correction is less than 7. It is not, so we're going to skip that part. And so since the first two conditions return false, we're going to get down to this part where we set the value of needs correction to be 24. Okay. And so if I run this code, then needs correction should have the value of 24 after this. Okay. And in fact, it does. And so you can see I ran the code and now it's equal to 24. Okay. All right. So if you want to use an else statement, so actually, a common way to use an else statement is actually in combination with an if. Okay. So you don't have to do if else. You can just do if else, right? So you can just delete this part right here. And this is a perfectly valid kind of block of code right here. So you can say if this is true, then execute this. But if it's not true, execute that. Okay. All right. And so we can see here. So let me just change this up just so it's easy to see. Okay. All right. And so we can do an if else here. So it said if needs correction is less than 5, if that's true, then we can set this value equal to 5. If not, set the value equal to 25. Okay. All right. So when we run this code, and you can see that the value for needs correction does indeed equal 25 because this first condition was false. And so we jump into the else statement. Okay. All right. But the same principles kind of apply here. So if something does return true up here, then we just execute that part and then we don't execute anything else. Okay. So for example, if the if part here returns true, then we don't execute the else if or the else. Okay. So I changed the value of this variable to 1, right? And so since the 1 is less than 5, then we're going to execute this body here. And so we're going to set the value of the variable equal to 5 from here. Okay. And in fact, we see just exactly that occur. Okay. All right. So the logic, for the if else if statements, I think they're straightforward to kind of understand in theory or in concept, right? And so when we're kind of talking about it, it kind of makes sense. But things do certainly get pretty complicated, with the logic here. And so, whenever you see an if else if statement or an else statement in your code, definitely, sometimes it takes a bit of time. So definitely take your time, kind of read the code, understand it, understand what's going on, and make sure you understand every single case of the if statement. Okay. All right. Any questions on this? Okay. All right. So those are control statements. So that's if, else, if. Next, we're going to go to for loops. And so for loops are a very, very, very valuable part of programming just in general, because there's a lot of situations in programming where you want to repeat certain lines of code, either repeat certain calculations, repeat certain assignments, repeat certain variable assignments here, okay? And oftentimes it's a lot more convenient to write a for loop rather than copy and paste code, hundreds and hundreds of times. Okay. Especially if you're repeating code where they're not exactly the same lines, but there's minute differences between them, and we'll go over that in a second. Okay. So that's what a for loop is for. So whenever you see a for loop, you can tell that this is a part of code that we want to repeat, that we're going to repeat over and over and over again. Okay. And so the anatomy of a for loop, I think, is probably the most confusing part here. And so to execute a for loop, you need to write the keyword for. Okay. Then you need to write the header of the for loop. And so you need to define 3 different variables here. Okay. The first variable that you're going to define is the index, and so that is the counting variable. So we'll go over how to use that in a second. Okay. Next thing you're going to define is the starting value for the index. Okay. So that's the value that whatever the index is going to start at, and then the stopping value here, that's the last value that the index is going to visit. Okay. And then inside the body of the for loop is the amount of code, or the code that you want to execute, or the code that you want to repeat. Okay. All right. So the way to read the way to read the for loop in kind of plain human speak is to say that, all right, I have this code here that I want to repeat. I want to repeat a certain amount of times where we start the counter, right? Start the counter at this variable, and then keep repeating it until the counter reaches this variable right here. Okay. And even though it's not implied here, or even though it's not listed here, the implication is that, as you go from start to end, each iteration of the for loop increases the index by 1. Okay. There's ways where you can write the for loop where you increase the index by numbers other than 1. But if you don't indicate anything, or if you just use 2 variables here for the starting and stopping, the assumption is that it's going to increment by 1. Okay. Okay. So let me give you an example here. And so this is probably the most common example that we're going to use in this class. And so we're going to use a for loop to assign the values of a vector. Okay. In another example, we're going to use a for loop to assign the values of a matrix. Okay. Okay. And so this is the example here, right? And so let's again let's do this example live. Okay. So first, let me kind of delete this. So we're done with the if statements. Okay. Let me clear the workspace here. Let me clear. Okay. So I want to write a for loop to assign the entries in a vector. Okay. So first, let's do this. First, let's create our vector. So let's say vector, let's use the same thing. So let's use loop vector is equal to zeros. And so let's say that this is going to have the dimensions of, let's say, 11 rows and 1 column. Okay, so this is going to be a column vector. Okay. Right, so remember the zeros functions. Remember we used this last time. And so when you call the zeros function, it creates an empty vector, right? And so it's going to create a vector where every entry is 0. Okay. All right, so let me run this code just so that you can see. Okay. All right, so you can see here that I've run the code. I have this vector here, which is 11 entries. Okay. And so if I double click on this, we can see the entries in the vector, and you can see that they're all 0, right? So 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay. But the important part is that there are 11 entries here. So there's 11 spots for us to assign. Okay. All right, so we want to assign every entry in this matrix, in this vector. So one way that we can do this is we can literally do it one by one. So this is what we did last time. We can say loop vector at 1 is equal to 1. Loop vector at 2 is equal to 3. So let's say I want to assign the values of this vector to be all the odd numbers. Okay. So we have loop vector at 3 is equal to 5. Loop vector at 4 is equal to 7. Loop vector at 5 is equal to 9. Loop vector at 6 is equal to 11. Loop vector at 7 is equal to 13. You can see this. You're hopefully getting tired of this, because I'm also getting very tired of this. I've always wondered, as I'm kind of finishing this up, I grew up with kind of computers around in my life, and so I've I'm relatively skilled at typing, although you're probably watching me and say, he's typing really slow right now. But it must be really hard for an older faculty who didn't grow up with computers to be able to type quickly like this. And so, okay. So we can assign all the entries in the vector here, and so this will work. And so let me go ahead and run this code just to prove to you that this works, right? And so I've assigned the entries of the vector one by one, right? So you can see I'm using our variable assignment operator, so we're using equal sign. Okay? And I'm visiting literally every single entry in the vector and assigning them a value. Okay, so I've gone ahead and run the code, and you can see here that after I double click on loop variable, you can see that all the entries have the appropriate value. So 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21. Okay. But that was a hassle. I had to stall for time for for a good minute or so. And so, and this is a relatively simple example too. And so we'll definitely have more examples, especially when we're making our element stiffness matrices, especially when we're assembling our matrices that are going to have a lot more entries than this. So let's instead, so let me actually run this code again, just so we can reset. We've reset all the values to 0. Okay. Let's write the same code, but let's use a for loop. Okay, so I'm going to use for. Okay. So you can see as soon as I write for, it highlights in blue. Okay. Okay, so let's start our index at 1, and let's end at 11. Okay, because we want to repeat this loop 11 times. And then inside here, I'm going to say loop vector at the index is equal to. So we want the odd numbers here. So we're going to have 1, 2 times index minus 1. Okay, so this block of code here is going to do exactly the same thing as I had before, but with only 3 lines of code. Technically, only 2 lines of code, because this one is just n, so n doesn't really count. Okay. Okay, so I ran the code, and you can see here that we've created our vector here of all odd numbers. Okay. Okay, but there's a few things to unpack here, so let's go ahead and do that. Okay? So this for loop does the same thing as when we signed okay, so this for loop does the exact same thing as when we assign each value or each entry in the vector manually. Okay, so how do we do that? Okay. All right, so if you notice, one thing that I utilized in this for loop is this index variable, right? So this index variable, so if you notice that that's the same index that we defined here, okay? That index is a special variable. Right? It technically is a variable, so you can actually see that it actually shows up on the workspace over here. Okay. Right, so it actually is a variable that you can interact with, but it's used in kind of a special way, right? So this index variable kind of serves a couple purposes. So the first thing that it does is that it keeps track of how many times the loop has completed. Okay. Right, because ultimately we want this loop to repeat 11 times. And so the way that the code kind of counts this and the way that it keeps track of this is that it keeps track of this index variable and uses that to count. Okay. And so the way to kind of think about this is that each time the loop reaches the end, right? Or in other words, each time that the body in the loop is executed, okay? Or so that each time the loop iteration reaches the end, okay, the index variable will go up by 1. Okay. Okay. So remember how I talked about, that when we're defining the index variable, we have to define its starting point and its ending point here. Okay. So when this loop executes, right, the program knows that it needs to execute this code 11 times. And so during the first iteration, the index variable will have a value of 1. Okay. And so it starts with a value of 1. Then once it executes everything inside the loop, it then comes back to the top, and then it increases the value of index to 2. Before the next iteration. Okay. And so it keeps it, so this index variable is really valuable because it keeps track of what iteration of the loop that we're in. Okay. The program knows to stop once the value of the index reaches the stopping value, which is the other part, the other number after the colon. Okay. So that's the first role of the index variable. It's just simply just there to kind of keep track. It's literally just a counting variable for the program to know how many times we've executed this loop already. Okay. Oops. Okay. The other way that the index variable is used is that we can actually utilize this variable inside the body. Okay. Because it is a variable, just like any of our other variables. So we can reference its value whenever we want. Okay. And knowing the purpose of this index variable, knowing the fact that it's keeping track of which iteration, we can take advantage of this and use it within our computations and our algorithms. Okay, so since the value of this variable will naturally increase as the loop iterates, we can take advantage, we can utilize this in our computations. Okay. Okay. So the number one way that we utilize this is through the assignment of vector entries. Okay. Because we want to assign every entry in this vector, right? So we want to assign entry 1, 2, 3, 4, 5, 6, 7, right? So if you remember the way that I had the code before, we had loop vector at 1 is equal to 1, loop vector at 2 is equal to 3, right? All these lines of code here are very similar to each other, but there's only one difference. So the difference is that we're referencing different entries in the vector here, okay? And the value here is changing as well, right? So we're doing all the odd numbers, right? So we can bake that into our for loop if we make use of this index variable, right? Because we know for a fact that this index variable is going to start at 1 and then count its way up to 11, right? And so we know that if we plug this index variable in here, right, or into our vector assignment, we're going to be able to visit every single entry in the vector and assign its value. Okay. So that's one way, right? And so to use the loop index inside the variable assignment or the vector assignment is very important, and that's a concept we're going to use a lot in this class. Okay. The other way that we use the index in this example is that we're using it to count the odd numbers, right? And so we don't want to kind of repeat odd numbers. We want to make sure that we're counting upwards, right? And so the way to kind of count up the odd numbers is to take the index, we multiply by 2, and then we subtract 1 from that, right? And so that's a way we can get the odd numbers. And so in this kind of very short, simple example right here, we kind of see kind of both applications of the loop index, right? Utilizing it in computations and utilizing it to reference entries in a vector, okay? So I would definitely, even though this is a very simple example, I would definitely kind of, really master it, kind of really understand kind of everything that's going on. Because these are things that we're going to use a lot in our codes from here on. Okay. All right. Any questions on this example here? Okay. Okay, let's come back to the slides here. Okay, and so on this next slide here, I've kind of unpacked it for you. And so, one way that you can kind of, if you're kind of confused about what a loop is doing, just unpack it. And so I would say that, a loop is nothing more than just, you're just repeating a set of lines of code over and over again. And so if you just unpack it and kind of think about kind of what's happening on each iteration, I think it helps a lot to kind of understand kind of what's going on inside that loop. Okay. Okay. So this is where things get a little bit crazy. So, we've gone over if statements, we've gone over for loops, but you can actually put if statements and for loops inside your if statements and for loops. And so, this is where I think this is where it starts to get a little bit hard to follow the code, right? So one thing that we may do, once or twice in this class is do what's called a nested for loop. Okay, and so a nested for loop is nothing more than just putting a for loop inside another for loop. Okay. And so this lets us kind of do a lot of repetition. Okay. Okay. And so following this can be a little bit tricky. So let's kind of walk our way through it. And so, when you have a nested for loop, usually I like to name my variables where I have one variable that represents what I call the outer index. And so that's the loop that's kind of on the outer layer. And then we have a loop on the inner layer, which I call the inner index. Okay. Okay. So let's follow the logic here. And so we know that when we take this outer for loop just as its own, right? And we consider this to be the body, right? This right here is the body of the outer loop. Right? So that means that every time the outer loop iterates, right? So every time it kind of, every time this index goes up by 1, right? That means this entire body is going to execute, right? And it just so happens that inside this body is another loop, okay? So every time the outer loop updates or every time the outer loop iterates, the inner loop will do a full cycle, right? Because in order for you to reach this part of the code right here, you need to complete this entire loop right here, okay? All right, so that means your inner loop here is going to repeat, many, many times, right? And so the analogy that I like to think of when I look at nested for loops is to think about a clock, okay? And so the outer loop represents something like the hour hand of a clock, okay? So these are kind of analog clocks. So you guys are grad students, I'm pretty sure you guys remember what an analog clock looks like, but I'm finding out from talking to my cousins that, my cousins don't know how to read an analog clock, which is crazy to me, right? So the outer loop is like an hour hand, and the inner loop of this loop here is like the minutes hand, right? In order for the hour hand to move to its next value, right? So in order for the hour hand to move from 12 to 1, the minute hand has to make a full rotation. Okay. And by the time the hour hand makes a full rotation, the minute hand will make 12 full rotations around the clock. Okay. And so whenever you see a nested for loop, it's I admit that even for me, it's tricky sometimes to follow the logic. But if you think about kind of this analogy of kind of the hour hand and the minute hand, I think it makes it a little bit easier to follow the logic. Okay. All right, we won't use nested for loops too much in this class. At least not as straightforward as at least not as kind of messy as this one. For your final project, I think there are a couple places where we'll use it. And so it's a good tool to have, but you're basically just applying the same logic of the loop twice. Okay. Yeah, question.
Would you have to reset the inner index back to 0 or 1?
It does it automatically. So every time you can see here that when the outer loop iterates, so it's going to reach the end here, right? And then when it comes back for the second iteration, you're resetting the inner index to whatever the start is. So every time this inner loop starts, it kind of automatically resets the index before doing another full iteration. Yeah, I think the tricky thing with nested for loops is that oftentimes what you want to do, and this is often in the body of the inner loop, is that you want to make use of both indexes, both the outer index and the inner index at the same time. So keeping track of which index is what and which one is doing what and what value that they're on. I think that's kind of the tricky part. But yeah, the index of the inner loop will automatically update once you get there. Yeah. Mm-hmm. All right. Any other questions on this here? So let's do a very simple example for nested for loop. And so kind of the easiest application for this, and let me kind of do this down here. Okay. And so kind of the most straightforward application for a nested for loop is going to be to assign the values of a matrix. Okay. So let's say assigning okay. Because a matrix naturally has two dimensions, right? So it has the row dimension and then the column dimension, right? And so if you want to assign each value of a matrix individually, the most space efficient way to do that would be to use a nested for loop. Okay. Okay. So let's do matrix, or let's do loop matrix. Okay. Once again, I'm going to create an empty matrix, and so let's say zeros. Let's make it 11 by 21. Okay. So pretty big matrix here. So, you know, we're gonna have 11 rows and 21 columns. Okay. Let's make it even actually. Let's just make it 10 and 20. I don't know why we're doing 11 freaking odd numbers and prime numbers and whatnot. Okay. So let's say that we want to assign every entry of this matrix here, right? Okay. So let's do 4. We want to have one loop iterate over the rows. And another loop iterate over the columns. Okay. Just so that we visit every single entry in this matrix. Okay. So let's have the outer loop here. It doesn't really matter which one's which for matrix assignment. You can do the column vector, the column loop on the outside or the row loop on the outside. But just because, you know, this is just how my mind works. So let me do 4 row index is equal to, okay. We want this to loop over however many rows that we have in this matrix. And so in this case, we have 10 rows. And so we're going to go from 4 is equal to 1 to 10. Okay. And then we're going to do 4 call index. Okay. Is equal to. Since we have 20 columns in this matrix, we're going to do the column index is going to go from 1 to 20. Okay. And then n. Okay. I need 2 end statements here because one end statement is going to be for the outer loop and one end statement is going to be for the inner loop. Okay. Okay. And so we want to do an assignment. So we're going to do loop matrix. Okay. We want to assign a particular value in this matrix. We need to give it its row index and the call index. Okay. And then let's assign it a value of, let's just take the sum of the two. So let's take row index plus call index. Just keep it simple. Okay. So at each entry of the matrix here, we're going to just have the sum of the row, whatever the row index is, and the column index. Okay. Okay. So let me go ahead and clear this. We don't need that loop vector anymore. Okay, so I'm going to run this code and we're going to look and see what this loop matrix looks like. Okay. Wrong button. Okay. So you can see here we have quite a few variables that were created, and actually I should have probably deleted this code up here. But you can see here we have the previous loop vector and the previous index. Okay. Here we have our loop matrix, so that's what we just created here. But we also have variables for the row index and the column index. Okay. And so if you notice here, you know, the values of the loop indices are always at the endpoints by the time you finish the code. Okay. And that's not by accident, right? And so remember, when you're done executing the loop, right? The way the program knows that you're done executing the loop is when these indices reach their stopping value, right? So every time you run a code with the loop, right, you should see all the loop indices appear in the workspace, and they should have a value that equals to their stopping value, right? So row index has a stopping value of 10, right? And so row index 10, and then our column index stops at a value of 20. And so we have call index 20. Okay. Okay, so let's look inside what's in the loop matrix here. Okay. All right, so remember, the way that we assign these values here, and let me maximize this just so it's a bit easier to see. Okay. The way that we assign these values here is we took the sum of the row index, which is just whatever this entry is right here, and the column index. Okay. So in this top left corner right here, we have 1 for the row index, 1 for the column index. 1 plus 1 is equal to 2. Okay. And so you can see here that we've assigned all entries in this matrix, right? And there were a lot of entries in this matrix. So there was 10 rows and 20 columns. And so that means there are 200 entries in this matrix, right? And so we were able to do 200 assignments, but we were able to do that in basically just 3 lines of code here. Okay. 3 lines of code and 2 end statements. And I don't really count the end statements. Okay. All right. Any questions on the nested for loop and kind of how that works? All right. All right. So that's good. Okay. And so the last thing that we'll do here before we jump into a couple examples. So I want to do a couple examples just kind of show you how to put everything together. But the last kind of crazy thing that you can do, the one that's kind of most common, is to put an if statement inside of for loop, right? And this is actually kind of where an if statement really shines, because the way that we used the if statements before is kind of almost very basic, and you kind of knew what was going to happen beforehand. But if you use an if statement inside a for loop, right, and you put the loop index inside the if statement, right, what this allows you to do is that it allows your code to do different things on different loop iterations, right? And that's very valuable because there are certain times where you need to do different things on different loop indices. Okay. All right. So let's do an example here. And in fact, I'm going to use the same nested for loop, okay, just to kind of illustrate to you kind of how to use this. Okay. So let's say that we want to write this code. So we want to do the same thing, but we want to skip assignment whenever the column index is even. Okay. So whenever the column index is even, we want to skip that column. Okay. So to do this, basically what we're saying is that we want to loop from 1 to 20, but we want to skip all the even columns. Okay. So that means that every iteration of this loop, we want to do something different depending on if our column index is odd or if our column index is even. Okay. Okay, so to do this, we need an if statement inside our for loop here. And so we're going to use if mod call index, comma 2. Okay. If this is equal to, or I should say, if it's greater than 0. Okay. I'll explain the mod function in a second. Okay. Then we have loop matrix at the row index, comma call index is equal to row index plus x. Okay. So this code right here will only execute, or this statement here will only return true if the column index is an odd number. Okay. And so how do we know if it's an odd number? So we use this function called mod, right? So mod here stands for modulus. In fact, actually, let me write it down here just so it's easier to see. And what the modulus function does is that it takes the first number, divides it by the second number. Okay. And then what it does is that instead of returning to you the result of the division, it basically treats that division as integer division, and it returns instead the remainder. All right, so this kind of goes back to, maybe elementary school for you guys, division with remainders, right? And so basically what we're saying here is that if the division between the column index and 2, if its remainder is greater than 0, then we know it's an odd number, right? Because any even number you divide by 2, it's going to be an even division, right? So there's going to be no remainder there. But if it's an odd number, if it's 1, 3, 5, 7, 10, or 1, 3, 5, 7, 9, 11, 13, 15, right? We divide by 2, we're always going to get a remainder of 1 if it's an odd number, right? And so if the modulus of the column index and 2 is greater than 0, then we assign this, then we do this assignment here, okay? Okay. So very quickly, just by using basic for loops and if statements, I'd say we got a fairly decently, complex code. So let's go ahead and run this, right? And if this does what we want it to do, then this matrix here, then it's all the even columns here should be 0 because they're going to remain unassigned. Okay, so let's go ahead and do that. So let's go ahead and run the code. Okay. And you can see here that our matrix here has changed, where all the odd columns have their values assigned, but all the even columns are 0, okay, because we've decided to skip them. And every time we run this code, we run the code from top to bottom. We are resetting the loop matrix to be zeros, for it to be an empty matrix before we jump into this nested form. Okay. All right. Any questions on that example there? Okay. All right. And so that's all of the control statements, right? So we have if statements, for loops, nested for loops, if statements within for loops, and so a combination of these things is we're going to use quite a bit in this class. Okay, so definitely something good to get used to. Okay, all right. Ooh, 6:30. Okay, so let me do one example here. Just because this is a good. Actually, let me do an example with if statements. Okay. Let me do example 2 here because I do want to talk about plotting right before we go today. Okay. But let's do an example here. Another example of for loops if statements. I think that's kind of the most difficult concept to grasp here. Okay, and so in this example here, we're going to start with an empty vector. So we're going to start with a vector with 25 entries. We're going to loop over each entry, and we're going to modify the entry according to the following criteria. Okay, so if the index is an odd number, then we're going to change the value of the entry to 1. Okay, if the index is a multiple of 4, then we're going to change the value of the entry to 4. And then in all other cases, we're going to change the value to 24. Okay. All right, so the answer is down here, but just for the sake of argument, let's go ahead and break this down and write the code for it. Okay. So let me do kind of picture in picture here. Okay, so here's the problem statement. So let's go ahead and write our code here. Okay. So we're going to start with an empty vector, right? So whenever we see empty vector, we're going to use our zeros function. Okay. So let's do example 2 is equal to zeros. And we want this vector to have 25 entries. So we're going to do 25, comma 1. Okay. It's a vector, so we have to do comma 1. So that means our second dimension is going to be 1. Okay. Okay, so we want to loop. So the next thing the problem says, we want to loop over each entry. So we're going to do loop for x2 index is equal to 1 to 25, right? So since we want to visit every entry of this vector, we're going to loop from 1 to 25 here, okay? And then depending on the index, we want to do something different, right? So that means we're going to do an if statement here. Okay, so let's break down this if statement kind of line by line here. So first thing we're going to check. So first thing we're going to check to see if the index is odd. So we're going to use our mod function. Okay. We're going to do mod x2 index. Okay. We're going to check if it's odd. So we're going to use the same code that we did up here, right? So to check if it's an odd number, we're going to do mod the index and 2 if it's greater than 0. Okay. Then we're going to change that entry to 1. Okay. So we're going to do example 2 at x2 index is equal to 1. Okay. All right, but we have multiple conditions here, and so we're going to do another check. Okay, and so to do another check, we're going to do an else if, right? So next thing we're going to check is if this entry here is a multiple of 4. Okay, and so if the entry is a multiple of 4, that means if we divide it by 4, it should give us a remainder 0. Okay, and so we do mod x2 index, comma 4, if that is equal to 0. Oh, by the way, we haven't used this before, but if you're going to write an if statement and you want something to be exactly equal to, you have to do equal. Okay, it's a little bit strange because normally you would think it's just equal sign, but the equal sign is reserved for assignment, right? And so we don't want to do any assignment in an if statement. We just want to check to see if it's equal to. So we're just going to do equal. Okay. And so if this were the case, if our index here was a multiple of 4, then we're going to set its value equal to 4. Right? Right. So that's kind of what the second part of the if statement says. The last thing we're going to do is that in all other cases, and so if the index is not an odd number, if it's not a multiple of 4, so if it's an even number, not a multiple of 4, so 2, 6, 10, 14, 18, 22, right? So those are all the cases. In those cases, we're going to set our value here, x2 index, equal to 24. Okay, and so when we run this code, we should see, we'll be able to examine all of the entries in this vector, and we should see that it follows this criteria here. Okay, but I want to do this example just because first of all, I think this kind of puts everything together here, we'll see an example with for loops and if statements. Okay, any questions on just the logic of this example here? Okay. All right, so let's run it and take a look. Okay, so we ran the code. Bring this over here. Okay. All right, so our workspace is getting a little bit messy just because we have a lot of stuff here, but let's look at example 2. Okay. And you can see here that this vector here satisfies our criteria. So for all the odd entries, so you have 1, 3, 5, 7, 9, right? All of these have an index of all of these have a value of 1 inside the vector. Okay. All of the multiples of 4, so that's 4, 8, 12, 16, 20, and 24, right? All of these have an entry, all these have a value of 4, because that's what our else if statement decreed here. Okay. And then in all other cases, and so for cases where both conditionals here return false, then we assign a value of 24 to this, right? So that's for entry 2, entry 6, entry 10, entry 14, 18, and 22. Okay. All right. So another example here of a for loop with an if statement inside. Okay. So we built this code here just based on the description of what was given to us in the problem. Okay. But it's definitely useful to kind of look at these solutions and try to understand kind of the logic behind them as well. Okay. Especially, if you haven't used MATLAB for a while or you're just kind of getting back into it, reading code and kind of deciphering what's going on and predicting the output is great practice. And I think something that I recommend for everyone. So, when you guys are kind of, going through and kind of getting used to MATLAB again, I would look at all the examples that we have here, and try to see if you can just read the code by itself and try to understand kind of the logic of what's going on. That's a great way to kind of practice code. All right, any questions on this? Okay. All right, so the last thing I want to do today is to go over plotting. Okay. So let me kind of highlight, maximize this guy again here. Okay, so plotting, plotting is something that's fairly unique to MATLAB, although Python has its own kind of way to plot things as well, and it's actually kind of one of the nicest features within MATLAB. It's just a way for you to kind of visualize data, visualize vectors, visualize matrices and so on. So the plotting feature is nice in MATLAB. Okay. And so the idea is a way to kind of take your vectors, take the numerical values of your vectors, and give it kind of a visual representation, either as a line graph, scatter plot, whatnot. Okay. And honestly, this is one of the best features of MATLAB, and no other coding language makes it as easy as MATLAB to kind of plot stuff. Okay. Okay, so to plot vectors, plotting vectors is quite simple. And so the only thing that you really have to do is you have to learn how to use this plot function right here. Okay. Okay. But you can see here, I've added another line of code here. So the other line of code here is I've added this figure parentheses 1. Okay. So this is optional. So I only do this just because that's just how I was trained. But MATLAB is smart enough to kind of put things in the right figure. Because when you call this figure function, what MATLAB does is that it creates a new window. Okay. This creates a new window for which you can put your plot onto. So it's for me, so the way I learned plotting was that you have to create the window first, and then you put the plot onto the figure. But if you don't include this, it's fine. MATLAB will just create one for you. Okay. Okay. And then the magic happens in this function right here. So you're going to call the function called plot. Okay. And plot takes at least 2 arguments. Okay. And so the first argument here, that is going to be a vector for the x-axis. Okay. So that's going to be a vector of data, right? And then the other entry you're going to put in is the vector for the y-axis. Right? So both of these are going to be vectors, and they're going to be, they have to be the same size. Okay. And so the way plotting works is that it's going to take each entry in your x vector, right? So let me kind of clear this. Okay. So let's say that you have your x vector here, right? And so it's a column vector. So let's say it has a certain amount of entries here. Okay. Okay. And you have your y vector. And so it has a certain amount of entries here. Okay. All right. So then what the plot function is going to do is that it's going to match up entries in your 2 vectors. So it's going to look at the first entries of both the x vector and the y vector, right? And this is going to be a pair of coordinates, right? So it's going to be an xy coordinates, right? Right. It gets the x coordinates from the first vector, the y coordinate from the second vector, and then it's going to plot a point according to those values, right? So let me call this x1, y1 here, right? And then we come over to your plot, right? And so we have the x-axis and the y-axis here, okay? It's going to place a point wherever you have x1, y1. So let's say x1, y1's right here, okay? Say x1, comma, y1. Okay? So that'll be the first point in your graph. The second point in your graph will be the second entries paired up, right? So you have x2, y2. Okay? So wherever that is, and so let's say we have x2, y2's right here. X2, Y2. Okay. Right. It's then going to connect them with the line. Right. Then it looks at the next entries. Right. So X3, Y3. Okay. So let's say X3, Y3 is up here. X3, Y3. Okay. It's going to connect them with the line. It's going to continue doing this until it reaches the end of the vector. So it's going to basically pair up the points between the 2 vectors. Okay. Going to take those as kind of ordered coordinates and then plot their locations in the plot. Okay. Okay. So let's look at a very simple code to kind of see how this works. Okay. All right. So this code right here, we're going to create an x vector. So the x vector is just going to be a linspace vector that goes between 0 and 5. It has 100 entries. Okay. And the y vector is going to be the x vector squared. So we're just plotting this, just a simple function y is equal to x squared. Okay. All right. So let's do this. Well, let's do it in line just so that you can kind of see. Okay. So let's come back to MATLAB here. Okay. So we're going to say x is equal to linspace, right? Remember, linspace is a function that we went over last time. Linspace takes three entries, excuse me. It takes the starting value, it takes the ending value, and it takes the number of points. Okay. So in this case, we want a vector that goes between 0 and 5, and we want 100 points in between them. Okay. Next, we're going to define a y vector. So y here is going to be x dot caret squared. Okay. Right. And so with this line of code here, we want each entry in the y vector to be the corresponding entry in the x vector, but squared. And so if you notice here, I used a very special notation here. So of course, this caret here, right? This caret is an exponential sign, right? And so this basically means that we're going to raise this to the second power, right? But if you notice, I included this period here, right? It's very subtle, but this period here is very important because, that period there, tells MATLAB that we want to apply this operation to each entry. Because remember, MATLAB sees these things as vectors, right? And so if you just do y is equal to x squared, right? It's actually going to try to square the entire vector. So vector multiplication. So vector 1 times vector 2, which creates, a matrix, right? So we don't want that. We want a vector of the same size, but every entry is the same entry as x but squared. Okay. So that's what that period does. It's an entry by entry or element by element operation. Okay. Very subtle, but very important. And we're going to see that again quite a bit in this class. Okay, so now let's plot it. So let's create figure 1. Okay. Right. Let me create the plot first, just so we can see. So we're going to do plot x comma y. Okay, so let's go ahead and run this. Hit F5 on the keyboard. Right. So you can see that after I run this code, it creates this plot for us. So it's a very nice kind of exponential plot here that goes from 0 to 5. Okay. And you can see that the ending point here is 5 comma 25, because that is what 5 squared is. It's 25. Okay. All right. So you can kind of zhuzh this up a little bit. And so if you want to add labels, if you want to add a title to your plot, you can definitely do that. Right. So let's say that we want to add a title. The title for this plot is plotting x squared. Okay. Let's do the x label. So we can label the x-axis. We'll call it x. And then the y label, we'll call it y. Okay. The labels are just nice to have. There's not much to it. You just enter the line of code here, and it has the labels for you. Okay. So let's go ahead and run the code. And you can see that we have the same plot, except now we have a nice title, and our x-axis is labeled, and our y-axis is labeled, right? And so if you're going to be using MATLAB to produce plots for like a formal report, it's always a good idea to label your axes, label your plots, just so people kind of know what they're looking at. Okay. All right. Any questions on this? Okay. All right, so we're just about out of time, so let's go ahead and call it here for today. And so when we come back on Tuesday, we'll actually start to implement what we learned. So, this week we just spent the entire week reviewing MATLAB. Next week, what we'll do is talk about how we can use this MATLAB to write algorithms to solve our direct stiffness problems. And so, we'll go through the logic of that. So I have a few examples with that, and we'll talk about the logic, and you'll see kind of everything that we talked about this week in terms of variables and if statements and for loops kind of implemented in practice. Okay. All right. So thank you guys for coming this week. I know probably this week's probably starting to get really busy for you guys because of midterms, and so I appreciate you guys coming out. Hope you guys enjoy your weekend. Hope you guys enjoy the rest of your day, and I will see you guys next week. Yep, you too?